Good evening, everyone. Today, we are going to talk about one of the most important building blocks of the internet, something that helps every computer, every phone, and even our smart fridge be able to communicate. Think of it like somebody trying to send a letter. When you're sending a letter, you have to make sure that it gets to the right person. And for that to happen, you need to have an address, right? Yeah. So it's the same to the devices because they are using the internet and they all need their own unique addresses to be able to send and receive information. That digital home address is called an IP address, which stands for Internet Protocol Address. And by the end of the lesson today, you'll understand that an IPv4 address is how it works and how it is so important and how we are able to express it in a simple way and be able to use it on our daily executions. IPv4 stands for Internet Protocol version 4. It's one of the main systems that help identify devices on a network. Think of it as the version of internet language whereby most devices still use it today. So each IPv4 address is made up of 32 bits. And these are tiny pieces of data that can be either a 0 or a 1. To make things easier for humans to read, these 32 bits are split into 4 groups of 8 octets. And then it is written as a regular number separated by a dot. As you can see an example that I have stipulated over there, which is 192.168.1.1. So while you see simple numbers behind the scene, the computer actually sees something big, like the binaries are so big, and the IPv4 can be able to create something that is about 4.3 billion unique addresses. Yes, that is how many homes that can be able to exist on the internet. IPv4 has 4 parts that are separated by a dot. So these parts are called octets or segments. Let's look at this example, the 192.168.1.1. So 192 is the first segment. Then the second segment is 168. Then we have the third segment, the fourth segment, which is another 1. So each of these numbers, they actually represent a binary code, and this is the computer's version of the language that is made up of only zeros and ones. And for example, as you can see, the 192 has 1 and then it has 1, 2, 3, 4, 5, 6 zeros, and then the next segment, as you see stipulated in there, until the 1. So when we put all of this together, we get 132-bit addresses that is easy for both people and computers be able to understand. Now, let's make things a bit smarter. So, CIDR stands for classless interdomain routing. So this classless interdomain routing helps organize and divide networks more efficiently. So instead of just having a plain IP address, the CIDR adds a slash and a number, like this example here, 192.168.1.1/24. So that /1 /24 tells us how many bits are used to be able to represent the network part versus the device part. So the first 24 bits, which are the three segments, they identify the network. And the last 8 bits are the are for devices that the host within that network. So in short, CIDR helps break large network into smaller version to make it easier to manage sections, like dividing a big city into small neighborhoods. So just like we have public streets and private driveways, IP addresses come into two main types. So we have the public IP addresses, and these are unique and very visible to the whole internet. And they are managed globally, so no two devices can share the same one. Think of it as your house number that anyone can use to find you on the map. Then we have the private IP addresses. So these are used only in the inside local networks. Like in our home Wi-Fi's or in our offices, we don't show up on the wider internet. So common private IP ranges include 192.16, and then, or if we start from 10 dot and then followed by other numbers. So many devices in our homes share one public IP address using something called a network address translation, so which acts like a reception and directing internet traffic to the right device inside our local network. So to make better use of our IP addresses, we use a process called subnetting. And subnetting divides one large network into smaller parts. So this makes management easier and helps control the traffic. So each subnet has a network portion that identifies which network it belongs to. And also it has a host portion which identifies a specific device on that particular network. So for example, we have the 192.168.1.0/24. So the /24 means the first 24 bits are for the network. So the remaining 8 bits can represent a device that allows it up to 254 devices in that group. So there are two main ways to give devices the IP addresses. So we have the static IP, which is manually assigned and stays on the same, and it is being used for servers or printers that always need a fixed address, doesn't move. But the dynamic IP is automatically assigned by something called a DHCP server, like our home router. So this can change over time, and they are perfect for everyday device like phones and laptops. And mostly this is just on the element of security. So most homes use dynamic IPs because it's simple and it's automatic. Like they have to have the fixed IP because of security issues. It has to be able to change automatically. So why does this matter? Every day we learn and we see new understanding of certain IPs that we use. So Why are we learning this? So we're trying to understand how IPv4 helps us see how every device, from our laptops, our smart TVs, they connect and they communicate. So it gives us a foundation to be able to troubleshoot connection issues or be able to set up home or business networks and be able to understand how data can be able to be transmitted around the world. So even though we know that IPv4 6, which is the newer version of even more devices, IPv4 is still the most widely used today. So learning IPv4 work, it's just on the aspect of technical, but also it's in the aspect of learning how the internet is able to speak to one another in the aspect of communicating and transforming data. And as we wrap up, let's remember that every time we connect to the Wi-Fi, we're able to stream a video or play an online game. IPv4 is quietly at work behind the scenes and making it possible. So understanding how IP addresses function, it gives us a solid foundation in networking and helps us see the invisible pathways that keep the digital world connected. Whether you're setting up your own network, you're solving a connection issue, or you're simply curious about how the internet really works, you have to have the knowledge and be able to think like a network professional and be able to understand how data is being translated and transmitted across the web. Thank you for listening.